Security teams are overwhelmed by alerts that slow delivery and still leave real risk behind. In this review, we break down how Endor Labs approaches application security with a focus on cutting noise and elevating the issues that can truly impact your software in production. By the end, you will understand how it works, the advantages and trade-offs, what it costs, and how it compares to alternatives. Let us start with the problem. Modern applications are assembled from open-source packages, internal libraries, and a smaller amount of custom code. In most teams, open-source components account for the vast majority of the codebase. Add the rise of AI-generated code, and you inherit more dependencies, more transitive chains, and more potential exposure. Traditional scanners enumerate every known CVE across that tree, but they struggle to tell you which vulnerabilities are reachable by your application and on what path an attacker could actually exploit them. The result is alert fatigue and long backlogs that do not move risk. Endor Labs takes a different path. Instead of measuring success by the number of issues found, it builds a software and dependency graph and asks a more useful question: which issues matter in this code, in this environment, right now? To do that, the platform ingests repository metadata and manifests, analyzes dependency relationships across direct and transitive layers, and correlates known vulnerabilities with call graphs and usage signals to determine reachability. If vulnerable code is not used, it is ranked lower. If it is used on a path that is exposed, it moves to the top of the queue. Do they use AI? The product uses data-driven techniques and heuristics to prioritize risk, and it continuously learns from code patterns across projects. It is not positioned as a generative chatbot. Instead, think of it as an analysis engine that applies graph modeling to help you make better decisions. In the context of AI-generated code, Endor Labs enforces the same governance you expect for human-written code. It checks package health, known vulnerabilities, maintenance status, and license constraints so you can accept or block additions with confidence. Key capabilities start with open-source risk management. The platform discovers direct and transitive dependencies, ties them to public vulnerability intelligence, and uses reachability to reduce noise. It provides practical remediation guidance, including safe version upgrade paths that avoid breaking changes when possible. Teams can export a software bill of materials, keep it updated across builds, and track drift as dependencies change over time. License compliance policies help ensure that copyleft or restricted licenses do not enter builds that go to production. Organizations can define rules that gate pull requests or block builds in CI based on severity, reachability, exploitability signals, age of the package, or license category. This keeps risky changes from merging by default, while allowing exceptions through managed approvals when business needs require them. For developer experience, findings appear where engineers work, typically in pull requests or backlog issues, so they can fix problems without leaving their flow. On integrations, Endor Labs supports common code hosts and CI tools. You can connect GitHub, GitLab, Bitbucket, or Azure DevOps, and plug analysis into Jenkins and other pipelines. For issue tracking, many teams sync with Jira, so prioritized work lands directly in sprints. IDE integrations are available for popular environments, giving developers feedback before code even reaches a pull request. Reporting is designed for both engineering and leadership. Engineers see a clear list of reachable and high-impact issues to remediate. Security leaders get dashboards that show risk trends across services, repositories, and business units, including mean time to remediate and policy coverage. This helps demonstrate progress to executives, auditors, and customers. Where does it fit among other tools? Think of Endor Labs as a next-generation approach to software composition analysis focused on prioritization. It is not a full-stack static analysis or dynamic testing suite. Many organizations pair it with unit tests, SAST, DAST, container scanning, and cloud security posture tools. When you compare it with SNCC, Sonatype, Mend, JFrog X-Ray, GitHub Advanced Security, GitLab Ultimate, or Veracode SCA, validate two things in a proof of value: how many findings become actionable because they are reachable, and how well the product integrates into your developer workflow without creating friction. Pricing is quote-based. Expect annual subscriptions sized to the number of developers or repositories, the languages and ecosystems in scope, and the level of support and compliance reporting you need. Most buyers start with a limited proof of value on representative services. A good test measures noise reduction, time saved by developers, and the percentage of critical issues that are actually fixed in the first month. Who should consider it? If you run many services, depend heavily on open source, and struggle with backlogs that never seem to shrink, the Reachability First model can help you focus. This is especially relevant for fintech, SaaS, commerce, and media platforms where frequent releases meet strict uptime goals. Regulated organizations gain value from SBOM accuracy, license controls, and policy-driven enforcement. Smaller teams with a narrow stack may find lighter weight SCA sufficient, but they can still benefit from the prioritization if transitive sprawl is a problem. What are the trade-offs? Because the product is aimed at software composition risk, it does not replace SAST for custom code logic flaws or DAST for runtime behavior. Coverage quality depends on the health of package ecosystems and the fidelity of call graph analysis. As with any AppSec rollout, the biggest success factor is adoption. Connect the tool to the places where developers work, make policies clear and achievable, and track the mean time to remediate as a core KPI. A note on the team and trajectory. Endor Labs highlights experience from Meta, Uber, Amazon, Splunk, Cisco, and Palo Alto networks. In India, Sriram Subramanian serves as Managing Director and R&D Head, reinforcing the focus on engineering depth. The company positions itself as one of the fastest-growing AppSec vendors, backed by venture funding and a roadmap centered on prioritization and developer experience. Implementation is straightforward. Connect your code hosts, select projects, run the initial analysis, and review the prioritized findings. Roll out policies in stages starting with monitor mode, then enforce on high-impact rules once teams are comfortable. Use dashboards to show progress and to identify owners for the top risks. Keep your SBOM exports current for compliance requests and customer questionnaires. Bottom line, Endor Labs is built for teams that want fewer alerts and more fixes. Its value comes from identifying reachable risk, enforcing clear policies, and meeting developers where they work. If you are evaluating the platform, run a head-to-head with your current SCA on a few representative services, and measure 3 things. How many findings get suppressed because they are not reachable? How many critical issues are resolved in the first 30 days? And how much time your engineers save per sprint? If those numbers move in the right direction, you have a strong case for adoption. If you want to go deeper, ask for a demo that walks through your own repositories, export an SBOM for one production service, and test a policy that blocks a known exploitable path. That will show you how the product behaves in your environment and whether the noise reduction matches the promise.